Welcome, everybody, to another edition of our Liftoff webinar series. My name is Joe Seal. I'm the Senior Director of Communications and Legislative Affairs here with LIFT. Well, thank you for taking some time to join us today and listening in and hearing from our member Solvus Global about innovation and incubation of and transition of advanced manufacturing technology, something that's critical, obviously, for us as an Advanced Manufacturing Innovation Institute and for you folks out there in the manufacturing sector who are trying to take some technologies through to commercialization. So thank you very much for taking some time to join us today. We have a few housekeeping issues to address before we get started. This webinar is being recorded, so please, you should be all on mute, but if you're not, please go ahead and mute your devices, your computers, to eliminate any background noise. So when this recording is posted on our website at lift.technology a little bit later today, there won't be any background noise. We will also be hosting a Q&A session after the presentation from Aaron. So please save your questions, or at least you can put your questions in the Q&A using the Q&A function we have here on the Zoom platform. Just click on that, fire in your question throughout the presentation, and we will I will facilitate the Q&A afterwards. So don't be shy. Please go ahead and fire away with your questions. So I do want to take a couple of minutes to talk about LIFT, who we are and what we do. LIFT is one of 16 National Manufacturing Innovation Institutes around the country. We are headquartered in Detroit and are a nonprofit public-private partnership between industry, academia, and government. So our mission is to drive American manufacturing into the future through technology and talent development. We do that through what we call smarter manufacturing, because as we know, on the manufacturing sector rests our economic security, our resiliency, and we know the next area, the next region that tackles smarter manufacturing first is going to come out ahead. And as the Department of Defense Manufacturing Innovation Institute, we really want that to be the U.S. So how do we do that? We do that through what we call the manufacturing equation, which is the connection of materials, processes, systems, and talent. So materials research, manufacturing process, the digital systems that kind of run underneath all of those, and the talent required to run all three of those things I mentioned previously. So we do that through two programs at LIFT. Leading Innovations for Tomorrow, which is our technology program, and Learning Innovations for Tomorrow, which is our talent program. A little bit about the technology program. You see the four pillars of technology that we work on at LIFT. All of our projects and programs fall under one of these pillars, as we're taking technology and trying to advance them forward across the valley of death into commercialization. We want to make sure that we can get these new technologies, new innovations in the hands of the warfighter, in the hands of industry to commercialize as quickly as possible. So we're glad to have Solvus Global here today talking about that transition. So you see a little bit more in depth about those pillars of technology here. I won't quiz you on these, but if you have questions, please don't hesitate to reach out to us directly. We'd be happy to talk to you and connect you to our technology team to see how we might help your organization move forward with any of these technologies. So a little bit on the talent side of the equation. Again, still here about innovation, but now we're talking about new learning tools, new pathways, new venues, and we really cover the students' really continuum through their education pathway, starting with our Ignite Mastering Manufacturing curriculum, which is a high school curriculum, foundational curriculum for high school students, introducing them to advanced manufacturing and driving them towards possibly becoming the next generation of multi-skilled technicians. We run that curriculum out of our LIFT Learning Lab that is in our Detroit facility. It's not solely at the Learning Lab, though. It is available in 10 states around the country. About 3,500 students are currently participating in our Ignite curriculum, but we tested it out here and ran it first in our LIFT Learning Lab. You see the Learning Lab there is really made of 7 different labs. Along with the high school curriculum at their Learning Lab, we also offer certification courses and certification opportunities for more mature adult learners. those are running and are LIFT certified, programs that we run through LIFT. And then we also have our Operation Next program, which offers the same 4 majors, if you will, but those are geared towards our active duty service members and members of the National Guard and Reserve. So we are proud to help those folks transition into their next career, their civilian career, help them earn a certification while they're on active duty, while they're serving the Guard and Reserve, free of charge to them. That is available in Fort Campbell, Kentucky. It is available to the National Guard and Reserve in Michigan, Wisconsin, Florida, New York, Alabama. It's also available to the Hampton Roads region of Virginia. So we're very proud of that program. I mentioned we are a nonprofit public-private partnership. We're also a membership-based organization. So I want to thank Solvus Global and their team for becoming and staying with LIFT as members. But what do you earn as becoming a LIFT member? Well, you earn all the things you see on the screen here. We're a trusted advisor, not selling a particular product or service. Want to guide people to make that transition towards smarter manufacturing as quickly and seamlessly as we can. We're a technology accelerator. Again, as I mentioned, taking those technologies across the valley of death into commercialization, and folks like Solvus helping us do that. We're a technology showcase, showing the art of the possible, and Sandbox, really, our technology team working out of our Detroit facility, showcasing the future, showcasing what is possible while sandboxing some of those technologies as well. We're a connector and a convener, which is why everyone's here today. So thank you very much for joining us, trying to bring the best and brightest minds together. Talent developer, as I mentioned, introducing high school students to advanced manufacturing, helping adult learners earn their certifications in advanced manufacturing. Want to make sure that that pipeline is healthy and robust. And finally, we are a government partner. I mentioned we are Department of Defense Manufacturing Innovation Institute. It is a challenge for small companies, particularly to begin to work with the Department of Defense or the federal government. So we are happy to help be that conduit and help folks start to work with the government and take those innovations to the warfighter and across to industry. So encourage you to reach out to us, follow us on our social channels. You can call us like olden times on the telephone, or email us or visit our website. Be happy to talk to you more about membership and how we can help you. But in the meantime, I'm going to turn the presentation over to Aaron Burt at Solvus Global. So Aaron, if you want to share your presentation, the show is yours.
Absolutely. Thank you, Joe. Appreciate it. All right. So hopefully you should all be seeing that now. Joe, can you just give me a thumbs up that we're good to go? I'm going to assume that's a yes.
Yep, I got you. Sorry.
All right, perfect. So here we go. First of all, thanks, Joe, for having us on here. Appreciate you guys being good supporters of the manufacturing ecosystem and community here. I'm just going to give a quick snapshot of everything that we're doing at Solvus, or at least some of it. It's a lot to cover, so bear with me. You're going to see a lot of different areas. So obviously would love to dive deeper in any specific area if folks have questions. So just want to start with a basic premise of Solvus, why we exist, and it actually mirrors LIFT's kind of primary core goals as well, really well, and that is that we're essentially a bridge between innovation and commercialization. We take responsibility for identifying major challenges that are out there in industry, kind of market level needs that are driving or preventing the future of an industry from growing. And we work with a bunch of different partners like LIFT, university partners, government partners, to bring technologies together and transition them to a commercially viable solution. And we take kind of full ownership and responsibility for making sure that those solutions are out there in the industry, in the marketplace, so that we can avoid having delays in adoption of technology. That's our fundamental goal. The way we do that is a little bit different. So we think that ideas are cheap. There's a lot of ideas. I have a huge list, like 300 things, that great ideas, right? But the problem is execution. That's the hard part. And so when we're thinking about these challenges, we're not focused on ideas. We're focused on execution. We're focused on making sure that the solutions that we deliver meet the specific needs of the end customers, whether they're defense, industry, private, public, it doesn't matter. The goal is to make sure that the solution is delivered. And the last thing is the number one resource is people. And Joe, I love that you mentioned the workforce development on the lift side. I mean, that's a huge part of what we see as is critical for the future of sustainable manufacturing industrial base here in the US is really taking advantage of the talented people that we have. So we are not a workforce development entity, but we do take great pride in supporting our team and helping our team members to grow in very different ways inside of the organization. We're a people first organization, and we're actually hiring and recruiting right now. So if you are looking for a role or know anybody who is, let us know. We have about 20 open positions ranging from materials to manufacturing technicians to PhDs. So would love to have you as part of our team. And really our goal is to help you grow to the greatest kind of heights that you want to grow as an individual. You want to be a CEO, we can help you get there. You want to be chief engineer, we can help you get there too. So come on down and check out some of what we're doing. We'd love to have folks on our team. So what is it that we do, right? What do we make? We make batteries, solid state batteries for lithium ion applications. So things like UAVs and UVs. We make metal powders and metal matrix composite powders for additive manufacturing, particularly cold spray and cold spray additive manufacturing. We build manufacturing intelligence software. So these are tools that interface with all kinds of machines and sensors and bring all that data into one data warehouse and let you store and share all that data across your kind of collaborative teams. We do a lot of work in large format casting and forging replacements using AM and related processes to robustify our supply chains. And lastly, one of our other big focus areas is developing software tools to enhance recycling profitability. So I'll talk about each of these kind of briefly in turn. We execute on the work through those different technology areas across a couple of different brands. So you can see the different brands across the right here. I won't dive too much into detail in them. You can see the list here, but Powders on Demand, obviously focused on AM powders. Our big business unit is obviously focused on large format AM, particularly metal. VALI-SORT is focused on those software products for scrap that I mentioned, Apex Manufacturing Intelligence. I'll talk a little bit about the action team at the end here, the CSAT and LSAT conferences. And then Kinetic Batteries is designing and manufacturing solid state lithium ion batteries. So again, we've got kind of 5 technology areas across these different brands. And that's what we do to help deploy these solutions out there into industry. So I'll touch on, again, some technology pieces in here that'll be kind of fun to talk about. And we can dive deeper if there's any specific questions that anybody has. So we are located in central Massachusetts. We have 3 different facilities, Worcester, Leominster, and a shared space with VRC Metal Systems down in Webster, Massachusetts. So we've got quite a bit of production space. We just moved into this space up here last June. It's about 70% programmed out already. So we're really excited to be scaling up a number of our operations. We're a relatively young company, relatively small, but growing pretty quickly. And we're excited to share some of what we're doing as part of these scaled up operations. So I want to start just talking about powders for cold spray, additive manufacturing, and beyond. A key part of what we do is really focus on designing materials that optimally perform in a given process. So a great example of this is our SAM aluminum 6061. As an example, you can take an aluminum 6061 powder off the shelf anywhere, and you can run it through a cold spray process. If you're not familiar with cold spray, metal powders into a high pressure, high temperature gas stream, you shoot those powders through a supersonic rocket nozzle. They travel really fast, hit onto a surface, they deform and they stick. In an as received condition, you're going to have a really brittle product. It might be fully dense, it might have great corrosion properties, but it's not going to have great mechanical structural properties. So what we do is we engineer that powder. We change things like the surface, the morphology, the microstructure, and we optimize it for a specific process. Not even just the process in general, right? Cold spray encompasses a lot of different technologies, but specific to the process performance that you can get with something like helium versus nitrogen, high pressure cold spray versus low pressure cold spray. We tackle all of those different areas, and we make sure that the powders that we produce can directly perform in the process that you're going to use. So the example here for aluminum 6061, you get a brittle product in the as received condition. When you use our product, which is a modified 6061, you're going to get near structural, near wrought type properties. So the idea here is that across all the materials that we offer, you can hit these types of performance metrics in your as-built state, in your as-built condition, or with minimal post-processing. So essentially, we optimize our materials so that they work in the best way possible in your manufacturing process, and we guarantee that type of quality and control. Another key piece of this is our ability to really quickly innovate and evaluate different materials. We understand kind of a physics-based level what's going on in the material systems during these types of processes, whether it's laser-based, it's kinetic-based, doesn't really matter. So we develop and deploy a number of different both evaluation and quality assurance tools to monitor these materials. The reason that matters is that for a long time, we haven't thought enough about what really goes into a powder, what really makes it work and function. So we look at things like size and geometry. We have a number of different techniques, a number of different attributes that we monitor here, from morphology, size, surface area, and all of that kind of fun stuff. Electrical resistivity of the material. This tells you a lot about the surface characteristics, microstructural characteristics, as well as some information about your size and sliding characteristics of the powder material. We look at something called compaction. So this is a high impact strain evaluation designed to evaluate the differences between the mechanical aspects of different materials. So you can see here an example of an unprocessed and a dried chromium powder. You get significant improved performance in the dried material, and we're able to evaluate that through our impact scenarios. And then lastly here, flowability. There's a number of different flowability techniques that are out there in industry, whether you've got Carney, you've got Hall, you've got flow block, rotary drums, lots of different techniques. The important part is that you understand in your given process, how is that powder actually moving? How is it actually flowing? So we take great pride in evaluating the flow characteristics of the powder material related to the process. So that gives you an evaluation in the kind of laboratory. How is this material going to perform in the actual deposition process, whatever that process may be? So we've deployed a number of these across, again, quality assurance, as well as material evaluation, screening, and development. So again, we can get to the ultimate goal of providing the right materials for a given process so that you get the performance targets that you need right out of the gate. We have a number of different capabilities in the background for doing that. Everything from sizing operations to surface modification operations, microstructural, mechanical modifications. It ranges the gambit. And really, it's a number of different capabilities that we deploy, as well as we deploy through our partners. So if we don't have the capability in-house, we have folks who can get it. If we don't have the material off the shelf, we have partners that we can work with to get you that material. So we can essentially be your one-stop shop for any process-specific powder material that you might be looking for. To give you an idea of some of those materials, again, you can see some of our aluminum product line across the top here. This is 6061, 7075, 2024, 7050. These are all designed for cold spray in particular. But out of these, again, you get near rot structural type properties. A number of different wear-resistant materials designed in collaboration with some of our partners at the Army Research Laboratory, designed for either hard-facing, corrosion-resistant, or some combination of both. They include chromium carbide-based materials, as well as tungsten carbide-based materials. We've got a few others that are coming down the pipeline here. So you've got things like silver, we've got a high nickel superalloy-based material, titanium, as well as some newer hard-facing materials, this WIP W2 designed to be sprayed in nitrogen applications. We've got some copper-coated tungsten, very good for electronics and kind of radiation protection. Some unique stainless steels that are coming out, designed for really high deposition efficiency in a nitrogen spray environment. If you're not familiar with nitrogen versus helium spray, you've got nitrogen is great for low-cost applications. Helium is great for high-cost applications. So you can leverage those depending on your kind of target performance requirements. We're working on some nitrogen sprayable aluminum products, as well as some different metal matrix composite materials for really, really high corrosion resistant applications. And there's a bunch more coming down the pipeline as well. So refractory-based materials, looking at some other alternative functional materials, as well as some additional corrosion resistant materials. So if there's a material that you're looking for in your specific application, let us know. If we don't have it, we probably have it in our development queue. If it's not in our development queue and it's a high enough need, we'll roll it out for you. We're here to ultimately serve our customers and serve the need base of the user community here. When we talk about the powder materials, in particular for cold spray additive type applications, the key here is that we're property first. So we're not just selling a product for the sake of selling it. We're really focused on making sure that the materials will meet your need, will meet the demands of your application. And so we put all that front and center We put it on a little QR code here so you can get access to all the materials, all of the information that you need to both qualify and assure your material, as well as select the right material for your specific application. When we look at this over, kind of a number of years, we design our materials to be fully inertly packaged, to be able to sit on the shelf for many, many years, and to be able to be used right out of that package. So the packaging has actually been modified since we first came out with some of these designs, but we've got a great example here of over the course of 4 years, an aluminum 6061 that we had processed that really, after that period of time, actually hasn't seen any degradation in the material performance. And that's because of the care that we take in processing the material, removing moisture, removing oxygen, packaging the material, so it can sit there and it can be ready to go when you need it, whether it's a point of need type manufacturing out in the field, or it's in the shop and you just haven't gotten to use that material in a while. We offer a variety of different packaging solutions. Again, depends on the product and what you're looking for, but everything from those bags that you saw a second ago to kind of forward operating type secure material transportation. So it could be a Pelican case, it could be some other secure vessel, but powder-based materials that are ruggedized so that they can go into a variety of different applications forward and beyond. So that's everything that I'll talk about today on powders. Again, I'm not diving into applications there. We've got material properties. If you want to talk applications, happy to jump in there offline. I want to switch gears a little bit to some of the data management activities. So for this, we'll talk about really a single kind of product focus here around the Apex platform that I talked about a moment ago. And this is really built out. It's out in testing in a number of different sites right now. It's in collaboration with the US Army, US Navy, VRC Metal Systems. What this is basically a tool that pulls together all kinds of different data streams from the manufacturing cell. So this could be a cold spray system. This could be a wire arc additive manufacturing system. It could be any other really manufacturing cell. Manages all of your different consumables, all of your different wearing components, stores, tracks those, and actually adds some intelligence in the background. So if you're using a worn out component or you're using a component that's maybe incompatible with something else, the system will flag it and recognize it for you. Offers full organizational management, so we can get in there and work with a number of different organizations. They can be distributed across a bunch of different geographies. This can be cloud-based, it can be local, just depending on your specific security and data sharing needs. You can get in here and you can really customize this depending on your specific application. Again, everything here is really teed up for a cold spray specific type application. But there's a wide range of systems that we can interface with a wide range of sensors that we can interface with. And all of these allow for, again, kind of streamlined, seamless data management, data sharing, and data storage. So I can kind of skip you through here to the process for a second. You can get a sense of that. So there's some intelligence added in here in the background. Basically, we've taken all of the processing conditions that we're operating at. There's actually a model built in here to recommend whether or not the materials that you're using are compatible with one another. And then you can see just a really simple operation with the process monitoring. So you can flag through a bunch of different sensors, whether they're on board with a PLC, they're off board in kind of a separate maybe profilometry or thermal camera based system. And you can see the types of data that we're able to capture there. And again, all of that is stored in the background. And you're able to use that for really, whatever purpose you want, sharing or otherwise. And the idea here is that interfaces with a wide range of different material systems and capabilities. So the kind of back engine of this in terms of some of the models and intelligence that we can insert in here, which is pretty neat. In this case, we have a nozzle clogging or fouling or wearing recommendation engine. So if you're not familiar with that kind of specific issue in cold spray, sometimes certain materials, as they're flowing through that nozzle that I described earlier, they're not compatible with one another. Maybe it's a hard material through a soft nozzle, so you start to wear away at that nozzle. Maybe it's a really sticky material through a hard carbide-based nozzle that tends to clog or foul. So essentially what we've done is gone through and broken out all of the different material components of a nozzle and of a powder, looked at a bunch of different experimental data, and we've put together this machine learning based recommendation engine that learns as you generate more data inside of your processing map. So it basically looks at all the different conditions, your temperature, your pressure, the materials that you're using, the specific nozzle that you're using, not just the type, but the actual nozzle identifier, and evaluates whether or not those materials are compatible. Recommends, hey, maybe you should change your nozzle. Maybe it's going to wear out over the course of this 2-3 hour spray operation because that nozzle's been heavily used, and makes those recommendations right in the platform. And this type of model is one that we've built, but we're actually deploying this as a tool so that essentially anybody can build models and deploy them into the specific framework. So maybe it's an alerting based model. Maybe you actually want to have a process control model. You've actually built out your own internal controls unique to interfacing, let's say, robotic path planning with different process fundamentals. That can all be inserted into this platform. And that's what makes it really, really powerful for scaling beyond kind of just the basic process operations. So in this case, you can see some of the types of powder properties that are brought into play, some of the specific nozzle history, operating conditions, again, across in this example of VRC Gen 3, and then the outcome, right? So this is basically a map of a bunch of different materials that have been sprayed in combination. And the system is basically looking at this process map and saying, okay, where does this new data point fall that I'm going to be spraying? Is it going to be in this kind of normal operation window, the blue space, or is it going to be more in that red zone where we have concerns over clogging occurring? And so that's where you get kind of a recommendation engine that we've built out specific to the cold spray process here. There's some other activities that we've done. I'll skip through this fairly quickly for the sake of time, but basically looking at hybridizing predictive models for cold spray, specifically looking at velocity calculations. This is more of a research and development effort, but if anybody's interested in collaborating in this type of space, we do quite a bit of taking physics-based models, hybridizing them, and then putting them into an environment where you can actually use them as tools, as resources for quick process evaluation, optimization, things like that. So this is just an example where you could take a fairly standard physics-based model. You could program it out in MATLAB or your other kind of programming language of choice. And running that operation might take you a few hundred seconds. You can really get in and tune that up, and it's still going to take you on the order of 10 to 15 seconds to run an operation. But when you hybridize it the way that we do, using different neural network configurations, we can get that calculation time down into fractions of seconds. And what that allows you to do is run iterative optimization models. It really kind of takes the best of both worlds. Your database processing combines it with physics-based processing and lets you do high throughput computation with relatively minimal effort. So if anybody wants to chat about that, happy to dive in deeper there. But I did want to dive in here into some of the large format additive manufacturing operations that we have going on. Again, the basic premise of this, I'll borrow from Dr. Aaron Wiest. I think he's transitioned roles since his shipbuilding industrial base task force days, but he's still working in this space. He really identified a major need in the Navy supply chain specifically, but this applies to really all supply chains in the US for casting and forging gaps, long lead times, materials that aren't available, a lot of overseas manufacturing that's just not available today with all the supply chain challenges across the globe. And so we really took this challenge to heart and we said, okay, what can we do to help step into this space? And so our primary focus is really on metal-based large format 3D printing, where we're not really looking at high resolution builds. We're talking about large parts. So many feet by many feet on a side. And we're focused really on material performance first and foremost. So a great example, obviously near and dear to the Navy's heart, is titanium. So we've developed a wire arc additive manufacturing procedure, working actually to qualify with NAVC under their new ArcDED Tech Pub, to be producing WAAM tie parts for the Navy. And the reason for this is that these are the types of parts that are very low availability out there in the industry today. Supply chain challenges, either very, very long lead times or no quotes. And with the wire arc additive process, we've designed and built our own inert enclosures. We've qualified these materials. They meet and exceed all casting requirements. You can see down here at the right, very consistent build operations. And what that allows us to do is basically have an alternative to cast titanium parts. These are non-structural, right? So we're talking cast here, but they're able to serve as a supply chain remediation for in particular these types of components that are no longer available in the supply chain, or we've got ships or aircraft that are sitting in dry dock or on the ground, not in operation, because they don't have parts. And so additive manufacturing can come in here and remediate that challenge. Again, I'm not talking about any specific parts here because it's a public forum, but you get the idea in terms of the material properties and the performance that we can get out of this. Looking at a few other technology areas that we focus in. So cold spray additive manufacturing is a big one for us. We talked about some of our aluminum 6061, some of our nickel-based superalloys that we've developed. We've also got a number of different copper and refractory-based materials that are coming into play now for additive manufacturing purposes, as well as combination, right? So AM with cold spray, and then combine that with a surface modification based on maybe a wear-resistant material. All of that's kind of within the wheelhouse these days. Across the wire arc additives, so we talked about titanium. We also have a huge focus on high-strength steels and 4000 series replacements. So we're getting well in the neighborhood of kind of target applications for replacing things like your 4340, 4140 steels using, again, a wire arc process. And then a big lift in the nickel superalloys on the wire arc additive side of things. So these are used in a number of different applications, from obviously turbine applications to we've got some activities with PEO Soldier that we're developing some unique solutions for. And these are, again, high strength materials designed property first, focused on performance-based applications. And then lastly, over here on the right, a relatively new area for us compared to the others, but this is friction stir additive manufacturing. We primarily focus on 6000, 5000, 7000 series aluminum alloys. These are a lot of development activities. We're looking at the same kind of idea, but now focused more on your forging replacements. So getting wrought-like properties right out of the gate with friction stir additive. So I'll show you a video of that here in a second, but just gives you an idea of some of the different materials and kind of capabilities that we're looking at as being solutions for this large format casting and forging replacement in kind of the domestic supply chain here. A few of the different systems that we have coming in or are already coming in, a number of different wire arc additive cells, a number of different cold spray additive cells, both large format and more traditional. We've got a fairly large wire arc additive machining and heat treating line coming in. We're pretty excited about this. It's going to be a fully integrated line for going from a wire arc additive cell, doing your heat treatment, putting it in your machining center to run your finished machining operations and get it right back out the door. This is actually in collaboration with the state of Massachusetts through the Mass Tech Collaborative Program. So this will actually be landing on our floor in kind of October of this year. So this is all getting to the idea that will be a one-stop shop for building your casting and forging replacement parts using additive manufacturing. Again, we're not particular to any one process. What we look at is what's the best process to hit your specific performance requirements, as well as your cost and lead time requirements. All of those things are what drive our selection. It doesn't really matter whether you want to use WAAM or friction stir or cold spray. What's best for your application, and we'll help you get there. And again, the idea is that we can do all of this in-house. That minimizes fuel consumption and transportation, eliminates a lot of the headache in your lead times, and eliminates some of the risk that you have when you work with a lot of different vendors. We're here as kind of one stop for all of your different needs in the AM production cycle. So just to give you a little flavor for what the friction stir additive system that we have is capable of doing. This is an aluminum 6061 build. This is a system designed and built by Bond Technologies out in Indiana. And you can see it's got an initial warm-up period there, and then we're depositing a layer. And these are pretty thick layers, right? They're anywhere from like 1/8 of an inch to 1/4 of an inch, really high fidelity in terms of what we're able to deposit here. Really unique machine. We've got load measurement capability on all of our axes. We've got torque monitoring, temperature monitoring, and we've got all kinds of hookups here. This was a system designed in collaboration with the Army Research Laboratory, so it's capable of doing in-process machining as well. Has all the right sensor IOs and outputs so that we can hook up essentially any sensor suite onto this that we want, so we can monitor all the various aspects of the build, whether it's load, its speed, its temperature. It's all built into that platform. We've got cooling capabilities. We can integrate other processes with this unit. So this is a little bit more on the research side, but it is scaled up and designed to be doing large format parts, so many feet by many feet. And we're working with a number of different partners and collaborators across the supply chain who are excited about having these types of capabilities, again, to get ROT-like properties in an AM process right out of the gate. So if anybody's interested in collaborating in this space, we're always looking for other partners to scale this technology. And I think I saw some of our partners from Bond on the webinar here as well. So obviously, if you have any specific questions, I'm sure more than happy to answer them as well. And then the last thing I'll highlight here is just some unique things that we're doing in the background in the world of large scale additives. So multi-material systems are a lot of fun. So this is specifically looking at wire arc additive, combining a high strength cobalt-based material like stellite with a high temperature nickel-based superalloy like Inconel. So we take these two materials so that you can have kind of the high strength and high wear resistance of the stellite in combination with the high temperature, high temperature and high strength applications of the Inconel, right? So you've got a material that is able to perform very, very well at high temperatures. You've got another material that's able to handle high wearing type operations. Combine those two materials together, and now you can have essentially a hard chrome replacement scenario, right? So that's a huge push across the DoD and a number of commercial areas as well, eliminating that hard chrome due to some of the toxicity of hexavalent chrome specifically. So you're able to use these types of additive systems to come up with unique material combinations that can target alternative structures, alternative designs. And so that's one of the things that we specialize in is come to us with a problem. We'll figure out what combination of materials, what combination of processes can get you to the solution as quickly and cost effectively as possible. Some other neat work done in collaboration with Professor Rhys Jones. He's out in Australia, looking at actually how can we take advantage of the surfaces that we get out of some of these large format AM processes. Obviously, that's one of the weak points of large AM. You build really fast, you get great properties, but typically your surfaces are not suitable for using it in an as finished or as built state. So one of the things that we're working with Professor Jones on is how can we optimize the surface topology of something like wire arc additive or cold spray additive so that you can use these parts in an as built state. Now that starts to eliminate, again, some of the lead time complexity of machining operations, finishing operations, really gives you a lot of flexibility when you're talking about internal features, internal structures. So what he's been doing is basically building models that simulate the surface topology. You've got kind of a sinusoidal frequency for some WAAM builds. You've got more different domain functions for cold spray or alternative wire arc additive builds, but essentially taking those, converting them to a finite element model, mapping the local stresses using actually an IR camera, which is really neat, and then taking that and converting it into a load type application, evaluating where is it going to fail, why will it fail, what kind of cycle life can we assign to it. And we've got some really exciting papers coming out with Professor Jones showing just how durable some of these materials are when they're coming out of the wire arc additive process after the heat treatments, because of the high cooling rates that you get out of WAAM. Because of some of the unique microstructures that you get out of this, you wind up with some really unique material properties, really high durability, really high strength. And so I'll make sure that Joe is aware of any kind of publications coming out of there so that if anybody's interested in that type of area, you can check out some of that work specifically. The last area that we do a lot of work in on the large format side is really in the sensor design and development. So we do everything from profilometry of wire arc additive beads for both quality assurance as well as quick screening. You can see some examples of that there. At the right, we've built out a whole tool for visualizing these profilometry runs from, again, this is just single line passes in a wire arc additive study, basically just looking at quick screening. When you see those little red dots, you know that that's a bit of waviness to your weld bead. So you know that's something that you don't want. You want more consistency to your builds. We install thermal cameras, spectroscopy units, velocimetry for cold spray. We do load cells, we do temperature, we do acoustics, all kinds of different sensory configurations built in here, really with the goal of being able to enhance the qualification process during build. I know that's what everybody's talking about in AM, but we really do focus on making sure that We can track and monitor every aspect of our build so that by the time we're done, we have a high degree of confidence that those builds, those parts that we're deploying are ready for prime time. There's minimal further testing. Obviously, you want to run your non-destructive testing, but essentially these parts are ready to go right off the shelf because, again, the in-process monitoring that's been deployed as part of these solutions. So just a bit of a flavor for some of that type of activity. I know we're running close on time here, so I'll kind of wrap things up with the last focus area for this afternoon. And that is our VALIS or VALI-SORT technology stack. If you look at the dynamics of the secondary material markets today, so those are materials that they've been taken from the ground as ore, they've been processed, put into a part, and now they're going back to scrap yards, right? You dropped them off at the local scrap collector down the street. They were sent to a scrap processor. Those processors are going to take and they're going to separate out the materials, sort them, and then they're going to send them back to the secondary consumers of those materials. Well, the problem is there's a lot of variability and flexibility to the supply chain right now. There's challenges with the stability. There's challenges with the global supply chain of all these different materials. Formerly, we used to send a lot of our scrap overseas. We're not able to do that anymore. So there's a really critical and pivotal need in the US in particular to be able to have more reliable supply chains of these secondary materials that can be used for high value type applications. So usually we take like a aerospace grade material and we downgrade it to like a cast A356 material in the case of aluminum. And that's really not where we need to be in terms of overall cost and performance going forward in the future. And so what we've designed at Solvus through this VALI-SORT technology is essentially a software that sits and monitors the sensor-based sorting systems, looks at all the market data, commodity data, brings that all into one location, and through our proprietary software, proprietary algorithms, makes recommendations for how you should be sorting your materials. So looking at the whole scheme of everything that you could be producing with this scrap that's coming down your line, it says, hey, based on what I see out there in industry and what's coming down your line, this is the best thing that you could sort into so that you can make the most money as a scrap processor. And what that does is it allows us to be more sustainable, and it allows us to design better alloys, better secondary alloys that have more high performing based end applications. So now we can design structural alloys, we can design wrought alloys out of secondary materials. This is really the future of sustainable closed loop manufacturing in the US, and it's a critical need for us going forward. The last thing I want to talk about here, just really quickly, a plug for the action team meetings in June of this year. So we're about 2 months away. The cold spray action team is running June 21, 22 at the DCU Center in Worcester, Massachusetts. We're expecting 200 to 300 people talking about cold spray additive manufacturing at the point of need. We've got VRC, we've got Speed 3D, we've got Titomic, we've got Centerline, we've got Impact Innovations, we've got folks from Caterpillar, Westinghouse, PNNL. It's going to be a really, really good show. So if you're at all interested in cold spray additive, definitely come check that out. You can see more at coldsprayteam.com. And then the sister event to this, the large scale additive action team, is happening June 23rd at the Worcester Polar Park, just down the street from the DCU Center. So same town. This is all focused on large format additive manufacturing. So we've got folks from the Navy, Army coming to talk about supply chain challenges. We've got folks from Icon doing 3D printed homes. We've got folks across the supply chain looking at different types of large format additive, from your powder bed to your wire arc to your friction stir. So definitely check that out if you're interested in the large scale additive side of things. And again, it's really just it's a user group, it's a user community coming to talk about the hard problems, hard challenges. And we're here, we just support it in terms of organizing, and it's a critical platform for everybody in the community to get together and have these kind of hard conversations about what are the challenges, what do we need to solve. So it's a good time. Definitely come on out if you are interested in either of those technology spaces. And again, you can check out the links below, or just reach out to me if you have any questions about it. And I think that's everything I have. I'm happy to take any questions. I know there's a lot of different areas, kind of diverse here. So appreciate Joe having the time here to chat with the group on call. And again, any questions, happy to take now, or if you want to dive deeper into anything, I'm happy to talk offline as well.
Awesome. Yeah, thank you. Great presentation. Appreciate taking the time today. And again, if you have questions, please go ahead and use the Q&A function. We'd be happy to address any of those. And you can also reach out to Aaron and the folks at Solvus Global offline as well. But Aaron, I wanted to ask you, you ran through a lot of different processes, a lot of different materials. Is there an area that is growing faster than others, or where is the bulk of the work that you guys do going? It seemed like there was a lot going on. Obviously, it echoed with we saw the pillars of our technology and some of the processes and materials that we're working on at Lift. So it seems like we were singing from the same song sheet. But wanted to know if there was a particular area that's growing faster than others, or where most of your work is.
Yeah, so it's funny. You know, there must be a reason that we're working together, right?
Exactly.
So no, there's a lot of growth right now in the large format additive side of things. So both, I would say that the cold spray additive and the wire arc additive are two really quickly growing areas. Reason for that is just the capability of those types of systems in terms of direct kind of CAD to part, in terms of the material properties that you're able to get out of it. So there's a lot of interest going into those spaces right now, and obviously the materials come in to support that, the software comes in to support that. So these are all fairly well tied together, but it's really that supply chain challenge is what's driving all of this. Everybody's looking for how can we reshore manufacturing, and ultimately, right, you know, we're not going back to large cast houses. It's just we're not competitive anymore as a country. So additive manufacturing makes sense, and so that's where we see a lot of the growth opportunities right now.
Right, and you mentioned the supply chain issues, and I heard you mention at the very beginning about powders and some of the things that are involved there. Can you talk a little bit about the availability, or I guess the availability in the marketplace of some of the powders that are required in some of these processes to make some of the components we're looking for, particularly on the DoD side, right?
It's a really interesting question. So yeah, there are increasing challenges in the material supply chain. One of the things that we specialize in is basically having multi-threaded raw material suppliers. And so we spend a lot of time qualifying a number of different suppliers so that they have equivalent performance in a process. And it's more than just looking at size distribution and chemistry. There's a lot of other things that go into that to making sure that you can have a like-for-like swap of different materials. But the reason that we've had to go that direction is because of those supply chain challenges that you're mentioning. I mean, especially nickel, cobalt-based materials, prices are going up, the availability is going down, lead times are going up. So one of the things that we do to help offset that for our customers is we basically, we take on the risk of inventorying everything. So even if a material is completely unavailable in the supply chain, we'll work with one of our many powders to make it available, because we have those types of partnerships and collaborations across the ecosystem. So yeah, there's definitely challenges, but we like to think that we've done a pretty good job of staying in front of them by identifying where those weak points are and bringing multiple players to bear where it's necessary.
Right. And then finally, you mentioned you know, a lot of additive work, whether it's WAAM or some of the friction stir. You showed the videos of that. How does that translate to making things at scale? You know, some of these processes are I don't want to say unique, but they're for one-off parts and pieces. But how do we take these technologies, take these processes, and really scale them up so we're able to make more and more of the components that were required? Even if this is the right way to make them, then it's the right way to make them. But how do we scale those up? Is that something that's down the road?
So I think there's a couple of different ways to think about that, right? And that's the cool part about additive is you can either scale with let's use WAAM as the example, right? One machine, multiple heads. ORNL has done a lot of that work. And there's a number of others that are looking into you know, how many welders can I put on at the same time and
Right.
build a part, manage my heat buildup. But the other thing is, a lot of these processes are relatively inexpensive. So a reasonably priced WAAM cell is in the $200,000 to $300,000 range if you're not talking about adding software and environmental controls. And so with that in mind, you can deploy many of these and build in parallel. And now when you do that, you've got to start talking about how do you create equivalency across the different platforms. And that's where some of that end process monitoring comes into play. So I think the future of scaling these types of technologies is really about understanding what are the basic physical phenomena that are occurring in the process. How do I measure all or some of those physical phenomena, whether it's temperature, it's pressure, it's current, it's thermal dissipation, whatever it might be. You're going to monitor those different attributes. And that's what you're going to use to kind of calibrate and create equivalency across your different systems and platforms. And so that's where having a kind of an established calibration standard for a machine, having sensors that are well calibrated, understanding what the physics are behind them. When you have that understanding, it's fairly straightforward to scale between different systems and platforms. And we've built parts on our cells across the course of years, and they behave identically. And the reason for that is because before every build, we go in and we calibrate. We recognize that, okay, there's something that's out of whack or there's not. And we've got those kind of standards in-house. So we know when things are performing the way that we expect them to, or when they're not. And so that's what it comes down to, is just making sure that we understand the AM processes, understand how to monitor them, and then understand how to assure the quality associated with them.
I said that was one more thing, but clearly I lied, because I now have one more, which is you brought up an interesting point in that answer about the accessibility and the affordability of a process like WAAM and starting up one of those cells. And that's certainly one of the things that we talk about at Lift is a process like that can help democratize the idea of metal additive in those processes, making it more available to particularly the small to medium-sized manufacturers who may have a robot, they may have some welding heads, but don't necessarily have the wherewithal to go about another metal additive machine or process. Is that and you mentioned earlier not going back to the big casting houses, is that kind of just where we are with these new and innovative processes, just making them more affordable, more accessible throughout the supply chain to make things to allow our small to medium-sized manufacturers to get in the game at a lower barrier of entry?
Yeah, I think there's definitely going to be a big push for that in the next couple of years. I think you can look at some of the major machine builders, the machine tool builders that are developing their hybrid platforms, right? You're starting to see CNCs that have powder DED heads on them. They start to have wire arc heads on them. You're starting to see some that even have friction stir welding or friction stir additive heads on them. So there's definitely a growing body of kind of available machines and drive out there that's saying let's standardize, democratize a little bit. I think the hard part right now is that that relatively low cost system that I described a moment ago, that doesn't come ready, plug and play,
right.
Build a part, you're good to go. Right. There's a lot of materials engineering, process engineering, and honestly software still that goes into getting those up to the point of being fully operational. So that's going to be the trick, right? The most user-friendly systems that get you your properties out of the box, that's what's going to win. And if you can make that low cost, then you've hit the sweet spot.
Yeah. Well, listen, I appreciate the presentation. Appreciate your taking time to participate with us today, and hopefully folks reach out to you directly for any follow-up questions or concerns. So thank you very much, everyone, for joining today. Thank you, Aaron, and your team. Everyone on the line, stay tuned to your emails as we continue down the road here with the month of May with Miller Electric talking on the talent side of the equation, as well as one of our larger companies, Raytheon, talking about some of the projects they're involved in. So appreciate you, Aaron, and your partnership and your membership, as you saw with the list of pillars of technology. And it makes sense, right? So glad to have you on part of the Lift Lift team, and glad to have you presented today. So thank you so much.
Absolutely. Thanks for having me. Take care.
Talk to you. Yep. Bye-bye.